Hey guys, this is Jeremy from Moralis.io. Welcome back. This is part 9 of the cloning Etherscan series. Last time we did up the token transaction result types. We added ERC20 tokens and the custom hook for helping us make the results more generic. This time we'll add a third tab here to do with token balances. And in order to do that, we're going to need a new cloud function. All right. So I'm going to grab this from the code here. Let's start at the code first. We'll need to modify our cloud queries file here. And I'm going to paste in this new function. Then we can go over it. All right. So we'll call this new function get token balances. It has the same parameters as before because it's going to be a paginated query. This is kind of like our nasty query up here in the sense that it uses the pipeline instead of just a regular query object. And because we're using the pipeline, we need to set it up into two separate stages. One where we do the count. So we provide our match conditions. Actually, it might be useful to take a look at the table first. Let's go back to the dashboard. Machine dashboard. And ETH token balance. So we looked at this briefly a little while ago. This is the table here. We've got the address. This is the address of the user. Then we have information about the tokens, the symbol, number of decimal places, contract type, ERC20, balance. So what we'll be doing, we'll need to do is match on the address to the current user that we're searching for. Then we can grab all the rows that match here. Back to the code. So that's the match stage here where we match on the address that's provided, the user address. We want to make sure it's a ERC20 token. And this balance, actually this also deserves some extra explanation as well. If we look at the table again here, the balance column here, notice this says string. So all of these balances are string values. So that means if we're doing a query against this column, that we won't be able to use greater than or less than, as those only apply for numeric values. So this is a string value because UINT256 values are very large, and they're larger than most of the standard data types, including like long. And it's also bigger than double because doubles are 64 bits. So you'd lose some precision by storing as a number. You can get some pretty large data types or numbers in Mongo, but you also, if you store this as a number, you also run into other issues with dealing with numbers in the JavaScript side. So these are all stored as strings. That makes our life a little bit more difficult. So that's why if we go back to the query here, we have balance not equal to 0. So we want to filter out all of the tokens that don't have a balance of 0. So we can't say balance greater than 0. We say balance not equal to the string 0. See, that's not the number 0, that's actually the string 0. So that works. So we use that as the match condition to for the first stage of the pipeline. So we can get our count. So we take this, the match, then we add the account stage to the pipeline, and that gives us the count. And then the second stage is doing the pagination. So we take the stuff from before, the match, add that to our pipeline. Then we need to add a couple of an extra field here. I've called this adjusted balance. And what this does is it converts the balance column to a double, and also the decimals column to a double because it's stored as a string. And then it divides that by the number of decimals so that we can get a number that's expressed in terms of that token. So if you have like an ERC20 token with 18 decimals, then we'll divide the balance amount by 10 to the 18th power to get the actual balance in terms of ETH for that token. So that allows us to sort by this new adjusted balance field. That way, it'll properly sort descending all the values. Because if you even if you convert the balance to some sort of integer value, you still can't sort on that because the number of decimals might be different. So this is one gotcha there is like Tether only has 6 decimal places, where say Ether and other ERC20 tokens have 18 decimal places. So Tether, if the user had any Tether, their balance would show up in the wrong order if you just sorted by the integer value for the balance. So that's why we do all this extra stuff. Then we sort, then we do the skip and limit. This is the same as the previous queries as far as pagination goes. So if you want to learn more about how that works, you can head over to the MongoDB docs. There's that's where you'll find a lot of these extra commands and pipeline operators that you won't find in the regular docs. Things like like the add fields and more advanced aggregation stuff. So hopefully that made some kind of sense. If not, just copy paste, go to the repo and copy paste this in, and all will be happy. Right. So once we get the count and once we get the results, we put it into the output like before, so that we have results as an array and count as the count, so that it can be consumed in the same way as our other cloud functions. Great. All right. So now that that's in there, I'll copy this and put it into the cloud server. Copy. And YouTube cloud functions. Paste that in. This is called get token balances. Save this. Now, what we need to do in order to get this working is actually surprisingly little, because last time we put some effort into making our components a bit more general. We added the use trans type hook, and all we really need to do is create a new entry for our hook here, and that'll kind of just work. So that's amazing. And let me copy in here. All right, so we'll create a new transaction type, transaction result type. We'll call this token balance. This will have just 2 columns, name and balance. Get token balances is the name of our new cloud function that we created in order to get the results for this. We'll need to create a post-process function to format the results properly. And this has something that we won't be using quite yet. Let's comment that out for now. So we got that in here, so that'll map to here once we have that. I'll create this one next. Go into the queries. We'll create a new file here. Call this token balance JS. And we'll export a new function called process balance. Just copy this in here. All right. Takes the columns from our function results and applies some formatting. We'll take the name and the symbol and combine it together like it is on Etherscan. Here, let me show that quick. Go over to Etherscan. This is actually displayed in Etherscan in the overview section here in a dropdown, but we'll be creating a new tab for it. So you notice we have the name here and the symbol, and then the amount expressed in that type of token. So go back to the code here. So we have name and symbol, and we'll keep the decimals and symbols in the result set just because. Then we'll use our token value text function from the utilities, just like last time, to output the token amount. Great, so that defines this function here. We can now import it. Good, so that adds to the imports. All right, so now this should define all of the state we need in order to display a new tab of type token balance. But this won't quite work just yet. There's one more thing we need to do here. Go to our address results. We need to add another link, navigation link, so that we can navigate to the new tab. So I'll just copy that in there, and we'll call this token balances, and type name here is token balance. So this will go to address / token balance. Great. All right. Is that everything? Let me just check the notes here. All right, we added the cloud function. Yep. Okay, we added the new entry and trans type options for the hook. We added the nav link to address results. All right, that's pretty much it. Let's save their results here and go to our. All right. Now we can see we have a new tab here called token balances, and if we click on that, boom, that just works. Just works. So you notice how simple that was now that we had modified our cloud function hook. And we can do this for another result type. Like if you wanted to implement the ERC or ERC 721 transactions, we could do that as well too. But I'll leave that as homework for you guys. You can try that out on your own. I'm sure you can do that now. The only thing is most addresses don't have those ERC21 transactions, but so it's you'd have to find an address that actually has them in order to make sure you can display them. We go back to our browser here. You notice there's an NFT token holders table here. And there's a couple other, so all of the NFT transactions would appear in these tables here. So if we watch an address with NFT tokens, there would be some extra ones here, and we could create a cloud function for that and go over the same steps we just did now in order to add that to our transaction results. Great. So that's amazing. Now there's one other thing here we could do quick is add a bit of styling to our to the result tab. So if we go to the address results, you can copy this here, address results, CSS, copy, add a new file here, address results, CSS, and I'll copy in some CSS that I borrowed from the Etherscan site. And here we can import that. Import address results CSS. And save. Now this will take advantage of the active class name. We've now defined that. Boom. Now you can see that it underlines the active result tab, just like it does in Etherscan here. So yeah, you can go through and add a bunch of extra styling. I won't do that. I'll leave that for you guys as homework as well. But yeah, I think that kind of wraps up this video, and probably wraps up this series for now. There's other things that we could do later on once we have more functionality implemented on the back end. There's other search types here. You can search by a transaction hash or block number and stuff, but there aren't API hooks for that quite yet. But perhaps we'll revisit that in the future. But until then, like and subscribe, comment below, and let us know how much you enjoyed the series and if you have any ideas for future content. Until the next video, we'll catch you guys later. All right.